All right, April 15, Sprint 3 deliverables was due last night. So if you're stuck on Sprint 3, come in lab time. Let's wrap it up. Now we have 1 week, 2 week, 3 week to work on Sprint 4, which is just cleaning up the UI, cleaning up the code. And I'll show you what I'm doing. And also start prepping for the final exam. So I'm just going to cover the final exam before I cover Sprint 4. So this is down here. We have final exam topics. This is in your class. Here we have Sprint 4 is going to be due this Sunday night at midnight. And then the final exam will be here on the 6th. So final exam, I shortened it down. Last semester, it was 20 short answer and like 30 multiple choice, about 50 questions. Nobody took more than like an hour. A lot of people are done in 30 minutes. I'm even shortening it down. It's 10 short answer, 20 multiple choice. So a short answer is just like a sentence, like what is a game object? What is a prefab? What's a transform? Just write a sentence within your own language what you think it is. Multiple choice is multiple choice. So here's all the topics. If you've been following with the videos, just building the project, it's all like should just be common knowledge at this point. It's just testing if you've been building your projects. So the Unity interface, the terminology, the windows, all the different sections like the hierarchy, the scene view, the project view, build settings, game object, prefabs, scenes, project hierarchy, children, transforms, components, creating your own components, i.e. scripts with C#. So some CS fundamentals, variables, hard-coded values, if statements, switch, loops like for each, for, while, methods, accessors like private, public, global, local, classes, libraries like using Unity Engine, enumerations. We do this a lot in the drop-downs, the kind of a mapping of one value to a string, references, and then some data structures that are specific to Unity, like vector3, which is 3 floats, quaternions, which deal with rotations, and colors, which are vector 4s with some additional parameters connected with that. Some basics of the primitives, cubes, spheres, cylinders, quads, planes. Modifying those primitives with shaders, materials, colors, animations, animators. We dealt with parameters and transitions on those animators. Ray casting into the world space from screen space. Mouse input, keyboard input, colliders, physics, rays, vectors. Building the UI, rect transform, screen space, global space. Canvas, elements like text, button, slider, toggle, drop down. Promoting variables to the inspector, promoting variables to the user, to the UI. Connecting the UI elements to method calls and sending information back to the UI. And I just had it in my mind, variables like ints, floats, spools. And if you refer back to my videos or just looking through your code to help study. But here's like, if you want, here's some Unity tutorials. So like, here's the interface. If you quickly needed like a 3-minute video on the scene view, you just click here. User interface, you need to recap what a button, an image, a text is. You can just go here. Some physics, animation, scripting. So these are all just like quick, like 2, 3, 4-minute videos. Is another training source if you choose to need it. So is there any questions on the final exam?
We feel that the final exam, let's say it's the worst case scenario, if you don't do well in the final exam, but you do well in like all the projects, would you feel that?
No. So projects are like 80% of the class. The final exam is really, it's very straightforward. If you've been working in Unity, just follow along with me. Like you'll do fine.
What's the format for the final?
10 short answer, 20 multiple choice. Short answer is just a sentence. Describe something to me. What's a prefab? It should really, the final should really just be like 30 minutes. You just come in, you deliver your final project, your sprint 4 deliverable the night before, come in for 30 minutes, you hang out, and then it just turns into lab time if you're stuck on anything. That's it. All right. So again, I'm down here all the way at the end of class. Sprint 4, that's Sunday the 5th. Final exam, the 6th. So here are the final exam topics. Here's where you drop your project deliverable sprint 4. I haven't put my example up yet. But here's sprint 4 deliverables. So I'm going to go over the project first, and then I'll go over this stuff. So this is it. This is my finished project. This is what we're going to work on for 3 weeks. So I can paint. Now I can paint behind the UI. I can hide the UI and maximize my painting area. I can bring the UI back. The UI has been broken up into sections. I tried to make it as logical as I could. I color-coded sections. But all this should be relatively familiar to you. So I have the painting area, color, size, glow, opacity. I'm going to turn off time destroy, but you know that this is the same. It's just that now the information is underneath it. And I'll show you what Sprint 3 looked like to remind you of. Actually, maybe I'll just do it now. This is where we left off. And so this kind of had an area about animation. This kind of had an area about like spawning and destroying, creating, destroying. This kind of had an area about like painting or coloring or something like this. So I tried to clean this up to kind of, now we're in wrap up phase, cleanup phase, refactoring. Let's clean our code. Let's clean our UI. So if I turn off time destroy, and I'm just going to increase the size. So I can slow down speed. Notice that all my paint strokes now can be changed size-wise. So I did end up fixing this one prefab quite a bit so that it was modifiable like the others. And I'll go over that next week. The glow works, the opacity works, all the different colors work. Now the speed of the animation goes from 0x to 3x. Before it was like in seconds, but I thought this made more sense, like how quickly do you want it? Besides going 1, 2, 3 for animations, notice how the type drop down changes. Notice how the type is now just 1, 2, 3. Since I did my headers out here and everything, I felt like I could simplify my drop downs. Just which animation type do you want? Now I can press 4, 5, and 6 to change my prefab spawning. So I can quickly change out my strokes that I wish to create. And if I clear this all out and I turned on random, notice how they're all moving at random speeds, but it's the same animation. And the speed factor doesn't overwrite all their speed information. They're all uniquely keeping track of all this random speed information I was giving them. And they're all slowing down and speeding up based on whatever their random speed factor is. It's not like overwriting them all, saying, no, make everything at 1.1 or 3. So now the speed slider recognizes the fact I'm actually storing a float on my animators now. Whatever was that random speed factor given to you at the beginning, you actually remember it. I'll cover that later. But now I fixed my prefab, so this whole section works. This is pretty straightforward. This is interesting. I can randomize my speed and then adjust how I want it. And if I clear that out, I can randomize the type of animation they're doing and then the actual speed of it. They're all keeping track of whatever speed they should be playing at relatively as we go from 0 to 3x based on whatever your initial speed seed was. And then if I just, let me get rid of random speed just to simplify things. Watch my animation type as I have random type now. The type value actually is keeping track. So before, when I was randomly spawning whatever animation each paint stroke gets, the UI wasn't keeping track of this, so then it kind of gets disconnected. So if I'm randomly generating animations and I end on like animation 3, my UI is still like showing that I'm on animation 1, and we're getting a disconnect that when we move forward and we're painting. So now all this random information is being kept track of here, and I turn that off. I'm actually painting out animation 3 on my strokes, where before it wasn't doing that, it was broken. All right, I did have a random area here. If this is like my stretch goal, so I'll turn it back on briefly. So we could randomize our spawn type and the amount of time it lives, but I don't think we're going to get there. Just know that if we do run out of content, I do have something to kind of fall back on. But this, I think, based on the way that last class went, I think there's more than enough. So we've cleaned up the UI. I went into the code. I cleaned a lot of issues. I went and cleaned up that prefab number 1 so that he is actually modifiable. All right. You can note that his color, his animation I removed, he's not doing that like rippling color. I simplified this prefab to be with the others because I'm just trying to wrap up the semester and make everything actually function with the UI. I'll take a look at this next week, why that color changed. But then the UI can move out, and you can paint over here, you can bring it back. I also disabled the button as it's moving because I could like spam the button and basically break it. This is animating by code, not by an animator, which I'm going to cover today to show you a little glimpse behind the scenes how complicated the animation system can be if you're doing it by hand. So I want you to do these type of features for Sprint 4, and I'll go over them. So I'll show you my listing of them. So here, the Sprint 4 deliverables. Clean up your UI into recognizable, distinct feature areas. Make sure all the features work on all your prefabs. Fix all prefabs so that the UI features work on existing paint strokes. Basically the same sentence. Animate your UI with code. Make sure to disable the hide button during animations to prevent user spamming. We're going to fix the click detector script so all the random features work as I just showed you. And make sure that the UI is tracking all these random changes. We've already hotkeyed 1 to 3 for animations. I want to hotkey 4 to 6 for the prefabs, and I'll make sure that the UI is keeping track of both of this information, both the swap animation and prefabs. Then clean up code, which I'm going to be doing. And just besides you actually posting your updated project, I'm going to ask you to take screenshots of your code and just describe what you cleaned up or fixed during the Sprint 4, just to show that, because if 2 students write the same thing, we know that you're cheating off each other. So something that you're really proud of, some section that you really like that you fixed, that you understood, yet maybe take a screenshot and talk about it in your posting. Take 2, right? So that's all I want for Sprint 4, and then we have the final exam. So any questions on Sprint 4?
For Sprint, there is no, like, I like to do like, after like Sprint 3, where like some prefabs don't scale right compared to the when you drag it. And
Sure.
like,
So-
sliders or something.
Well, yeah, so you can go over that in lab time. So anyway, down here, Sprint 4, I'll put up my example project, and here's what the final exam is about. All right. So in this class, we're going to cover updating the UI, animating the UI, and moving the paint stroke behind the UI. And then I got, I disabled the hide button to do that. This class. Okay, so this is what Sprint 3 looked like. Just to remember that the UI was starting to grow. We have a lot of buttons. So I decided this information I'm going to try and pull into my slider. This information I'm going to try and pull in my slider. I'm going to try and separate these areas out, give them names and headers, kind of shrink these down. Like I shouldn't really need to talk about these because I don't know what type of prefabs. I should just be able to label them 1, 2, 3. Same with this one, as long as the user knows what it is. And that's where we're at here. So first thing to note that the clock used to be up here. We used to have this quad turned on. So I had you first draw your background of your UI. This used to be like over here and scaled down as a separate 3D object called a quad, game object, 3D quad here. So I disabled that because I'm going to basically rebuild it as just an image, much simpler and integrated. And if you remember a few weeks ago, my canvas used to be in screen space overlay. It used to be like huge and off to the side, and I only used to render it to the camera. But I switched it over to world space so that it just sits right in front of the camera. It's going to be a lot easier for me to handle, especially now that I wish to animate it, which is basically just moving it left and right in the world. And maybe just as important is that no matter what the aspect, whatever the size is that's being rendered on the user's computer, everything kind of just stays as is because it's just sitting in the world and the camera is just rendering it. So first off, I took the clock, I moved it in. Even though the clock is a 3D object and the rest of this is 2D, they all can kind of sit together. And the benefit of that is that they all move together. So this is kind of my steps toward moving toward an animatable UI. This image is just game object UI image. And when we start off here, we just get a white square. And we can just change the color on it. In this case, let me find something I haven't used yet. Maybe like an orange. When you're picking your colors, normally I said stay off of this super saturated area. These days, something kind of muted out is considered like good design. So it's easy to pick a color, and since everything sits in world space right here, it's super easy to just drag it over, and you can open up the width and the height and just position it. Now notice how it's being rendered on top of the rest of the UI elements. So the actual order, when we're dealing with these 2D objects, this UI, the actual order in the hierarchy matters based on its rendering order. So as I move this up, maybe to here, let me just move it down. Notice how it's being rendered behind my paint sliders. And as I continue moving it up, if I move it all the way up, it's actually being rendered behind my main image. Let me move it down. So here it is. It's being rendered on top of my background image, but rendered behind everything else. And as I kind of, maybe I'll move it to this midway point, and you can see that there's certain objects it's being rendered on top of, certain behind. And so it really matters this order. So I ordered everything from like top to bottom and I tried to make sense of it. So this is how you can start to create these images. I'm going to delete this one. This is my background image. I'm just going to call it background. If I turn it on and off, that's the major canvas. And then you can adjust the position of it, the width of it. And so now I have like my 3D object, and I have my image background. One thing to note is this clock used to be back a little bit, and the quad was behind it. It's just the way I was positioning things. But now that I'm kind of placing all of my UI almost at a Z depth of 0, like at world space 0, the camera is over here, -10 on Z, it's off, and my whole UI is just at a Z position of 0. I'm just going to move the clock up a little bit. And I ended up scaling it and positioning it, and so can you. So that it still looks good, and now it's sitting right on front of my UI. The only thing left to talk about with this kind of like nested objects is that this AM button, notice how he's sitting on clock in front of the clock a little bit. So if I move it back to Z of 0, where he's sitting nicely with the rest of the UI, the clock is covering it. So I had to take the AM PM button and I just moved it out, and then just watching the game view, I positioned it in the center of the clock. So we have image background, we got our clock, we got our AM button, we're going well. As I move down here, all I did was I took this image background, I duplicated it, and just I moved the order of it. Let me make it something that's really recognizable, this lime green. And let me change the height and move it up. And all I did was change its height, change its color, and position it. In fact, I did this the last class. I think it was this text image project. Yeah, this didn't exist in the last class. So what I did was, oh look, I have nice little backgrounds on all my sections. Let me make another little background that's meant to be for my little title. But notice it gets duplicated. It's at the bottom of the stack. It's covering everything. No good. Let's move it up here. And I just did like a very light green. I adjusted the height on it and just kept moving it up. My height went negative. That's no good. And I'm kind of positioning it, scaling it, and it's above the text so that it's rendered behind it. And that's how I put my little color-coded background sections. So that had to deal with positioning, height, width I left as is, so that they kind of are the same width of whatever my big background image is, and they feel kind of like stripes or ribbons on it. Now, I start to group stuff here. So for example, the animation group, notice he's nice and easy to move around. And if I wish to make more elaborate animations where big sections are popping up and down, I can do so because I grouped them nicely. So for this animation group, I can open it up, and here's all the components of my UI that deals with animation. So this group, this game object, notice that it's actually just a text UI component. I just turned off the text element. So just a quick way, I just went in, you can grab anything. Say I wish to grab an image, just turn off the image part of it, and now it's just an empty game object basically that you can use to group parts of your UI. So then I can just call it like another UI group. I can drag stuff within it. So for example, button hide. And then as I move the group around, it just comes along for the ride. So maybe I want to put this group up here, and I want to put the clock. I gotta move it underneath the image. I'll move the clock in here. I'll move the AM PM button in here, and I'll call this my top, the top of my UI group. And I can reposition the whole thing as needed. So it's super useful. All right. So anyway, the animation group. I have my little background image. I already went through how to make that. I made a text element, and all I did was rotate it 90 degrees. And the reason I did that is because I'm trying to shrink down the room. So I thought, okay, maybe my little header sections can be rotated 90 degrees. They take up less room. So this is the animation section, and it has 2 rows, one dealing with the type of animation, one dealing with the speed of the animation. Same with here. There's the spawn section, type, time. So that's how I rotated the text. And if I choose to, I can duplicate this image, move it up a little bit, maybe above here, make it white. I can shrink down the width and just move it over here if I wish to have like a little section for my label to make it more eye-catching, that no, this is the little header for this area. So just know that you can build out your UI like this. So here's my text for type. It's just a text element, and I typed out type. Here's my drop down. This already existed. The whole features of it are the same. The only thing I changed was the names 1, 2, and 3. All right, because it says type now. I know I'm dealing with an animation type, and there's multiple ones. I don't need to name them anymore. 1, 2, 3. This random toggle I'm going to cover because he's a little nested object. I'll cover him last. Here's the text for speed. Here's my slider. So all I did was I turned off, I used to have this button element I turned that off. Then I took my text and I just moved it over and down, and I shrunk it down a little bit. I went from 14 to 12. And I just put an X. So 1.0x, most people know that's like full speed. So I changed this from a sec to an X. So I did it here, but I actually have to go into my script here. Change animation speed. This used to say space sec, and it used to be updated to the UI every time. All I did was change that to an X. I'm good. And so this is small enough you can still read it, but it's all like pushed together. I know what it's referring to. And so then I have my random toggle here. And if I open it up, you see I have the group of it just has an image, and it's just a white square, and I just sized it up to fill up the whole thing. And I have a little text. I rotated it to not 270 this time, so that it kind of angled in toward the UI. It's on the other side, just as rand. I think that's enough information to say it's dealing with random. And here's my 2 toggles. They've already existed, and all I did was turn off their label. I don't need them to say timer or whatever you type, or whatever they used to say over here. They said type and speed. I got rid of that. It's just a little toggle now, because it lines up. This one lines up with type. This one lines up with speed. They say rand. All right, I figure I cleaned up my UI nicely that way. And so that's the random group, 2 toggles within it, just laid out vertically. And everything's grouped nicely. So again, I can move it and deal with it as one big object. Is there any questions before I move on to the other groups? All right, next, spawning. I pulled the paint sliders in there by mistake.
So each section is can be object and everything over.
Yep. So not specifically a game object, some type of UI object. So for example, I can make a UI text. Just turn off the text part. It just has to be a rect transform, has a canvas render. All that gets attached if you just do a UI object. And then you can just use this to group.
It could be an empty space object too.
Space?
Yeah, an empty object.
You mean like a 3D object? Like these?
An empty, like where it doesn't create empty.
Oh.
Make it a less.
Yeah, the problem I have with this is that it's meant to be a 3D object, so it has a transform. So just to make everything clean, and I think it needs to have this canvas render on it to keep everything rendering to the camera. So whenever I'm working with any UI, just use these UI elements. Like maybe they should have like an empty UI element, but I just use one of these and I just turn off whatever their component is. And then I I rename it and I group stuff under it. So spawning, we got our image. I just duplicated it, moved it down, made sure everything was in order so that they're rendered correctly. So we just have the text that's rotated. We have type and time. I thought made the most sense. So this is my drop-down primitive. This is the same. Again, instead of cube, capsule, cylinder, or whatever it was, I just did 1, 2, 3 because now we're referring to our spawn type, so I don't need to talk much more about it. I thought that the destroy button made sense next to it. So if you're spawning something, you would want to destroy something. It's not time-based. So my slider is down here. So this has the toggle in it, whether it's time-based or not, and then the slider. And all I did here was just move the text again. So instead of there being a button that says like 3 seconds, or a non-interactive button, I should say, I just moved the text element down underneath and shrunk it just a little bit. I shrunk it by going from, defaults to 14 font. I just lowered it to 12. So that's my spawning section. And now I got my paint strokes. So here's just the background image, the text that's rotated sideways, and everything else was as is. I didn't even mess with it. And the mouse position stayed as is. So the only thing I've got to cover is the hide button. So before I go over that, is there any questions on updating the UI? All right. So again, I did leave room for this other random toggles, but I didn't build them out yet. And quite frankly, I don't think we're going to have time this semester, so I'm just going to hide them for right now. So button hide is just a button. So game object UI button. All I did was scale it, position it, change the text to hide. I did move the text to the side, and I purposely have the button kind of hanging off because what I want to get to is when I move this thing, I want it to be somewhere like that where I can kind of, yeah, it's hidden, but I can still click on this button and pop it back out. That's why the button's overhanging. So the only distinct feature of this button is that it's calling a new script. That's it. So since I'm animating at this level, at the root of the canvas, and I purposely moved my clock in, I redid my background of my UI canvas so that it's all in this group and I can move it all as a group, I ended up putting the script at this root level. So all I did was go down the folders. I created a new folder, Sprint 4. We haven't created a script in a while. And I just right-click, create C# script. And I just called it UI animation because that's a logical name for me because that's what I want to do with it. And I just drag it onto the root of my canvas. Once I do all that, I can start writing the script. All right. So this is the first time we're going to animate with code. It's a separate script that does just that, and it allows me to introduce 2 new concepts called the enumerator, or a coroutine, and lerping, or linear interpolation. So let me introduce one by one as we move through this script. So all you have to pay attention to right now is this method. This is a public method called moveUI. So the script is called UI animation. It lives on the root of our UI canvas and has a public method called moveUI. So that's why the button knows about the root and knows about UI canvas, and here's the method it's calling moveUI. A button doesn't pass any information, it just kind of executes code. We're not passing an int, a bool, a float, nothing. We're just executing this method. So we do have to know if the panel is hidden or not. So our first variable, our data member, private bool is hidden, by default false, because by default it's already showing, it's sitting out for use. Right? So whenever we call this method, the user's clicking on that button, we check. If is hidden, meaning the bool is true, meaning the UI is hidden, we do this. Else, the UI is hidden. I'm sorry, the bool is false. The UI is not hidden, it's shown. We run this. Whatever the situation happens to be at the end of the day, we're going to run this coroutine down here. So, what's the difference between these two? Is just this piece of data that we're passing into our coroutine, which is the vector that we end up moving to. So if we're currently hidden, we want to move to location, show position. If we're not hidden, we want to move to the hidden position. So show position, hide position. They're private vector 3s, x, y, z, 3 floats. They're recording our locations that we want to move to during our animation, or at the end of our animation. There's one more vector 3. We're keeping track of where we're starting from when we first start this animation. So a coroutine is like a separate thread. This is the first time we're doing any type of multi-threaded programming. The update loop is like its own thread. It's just working on itself in the processor. We're constantly looping on this update loop. So to do an animation, we're going to basically spin off our own thread. We're going to spin off our own little loop. And in that little loop, we're going to move the position information of our UI canvas. So to create our own little loop, our own little thread, it's called a coroutine. And to do that, we have a private method of type enumerator. We're going to call it moving UI. So you can see here the move UI calls moving UI. And we're going to feed in a vector 3, our end position, where we wish to get to at the end of our animation, at the end of our little loop that will move our UI step by step, very small, so it looks like a smooth animation. So to do that, to pass information to a coroutine, we kind of have to do this little convention, this little paradigm. So we're going to do a private, basically it's a reference variable of type enumerator. We're going to call it coroutine. Down here, coroutine equals what? It equals moving UI passing this vector or moving UI passing in this vector. We store it in this reference variable. We update our bool. If it's currently hidden, we're going to move to unhidden. So update our UI and vice versa for this side. But now we have a reference variable showing us which direction we're going to move the animation to. Then we actually run the coroutine. So this is a very unique method call. It's called start coroutine. In this case, we're passing in this reference, start coroutine. The only difference is which direction we're going to. At the end of the day, we start off and we just run through this code. This code, again, is spun off in its own little loop. It's going to run by itself for a certain amount of time, and then the loop will close when we finish our animation. So, to start off this little loop, we have a float called elapsed time set equal to 0, meaning we just started this loop, we just started this little time cycle. We're at time 0 of our coroutine. We're recording the start position, which is transform.position. So this script lives at the root of our UI. So transform.position is referencing this x, y, and z here, wherever we currently are. So even though it's a rect transform, notice as I move it left and right, position x changes, up and down, position y, and forward, backward for z. So this x, y, and z, these three floats, this vector 3, transform.position, is the same for this, even though it's a rect transform as it is to a regular transform. So we're just recognizing wherever we're starting this animation, this is our start position. I'm going to get to this later. I'm just going to comment this out, and I'm just going to show you that code. If I click play, if I'm quick enough with clicking, is I keep clicking and basically I'm breaking it. So that's why that script exists, and actually I broke it now because I can keep clicking that button. It screws up the code. So I'll get to this in a second. But we're passing in this end position. So let me talk about that here, what show position, hide position is. Because at the end of the day, that's what's getting passed into this enumerator method as end position. And that's what we're using. Where are we moving towards? So show position, hide position. When this thing is shown, it's perfectly sitting where it's at. It's in position 0, 0, 0. When I want to move it, I know I want to move it somewhere over here where it's kind of hidden and this is still sticking out. So it looks like it's super close to -6. So I can just take -6, 0, 0 as my hidden position. That's how I figure out what my two positions should be. So when this method starts, I'm going to assign these vector 3s. Show position, we already have a data structure for 0, 0, 0. I don't need to create a new vector 3. I can just use vector 3.0, which is, if I hover over it, 0, 0, 0. Hide position, I do have to create a new vector 3 because it's -6, 0, 0, and nothing already exists with that. No vector 3 already exists with that information. So show position, 0, 0, 0. Hide position, -6. Move to the left, 6 units. So that's what's being passed in here. That ends up being called end position. So I know my start position. In this situation, it's being shown. We're starting from shown, so start position is 0, 0, 0. And then we go while the distance between this and this is greater than 1/100th of a unit. So first off, the while loop will keep running while this evaluates to true. So ideally, it would be nice to say equals. So while, or not equals, I should say, while this number does not equal this number, keep running, and we'll keep moving them closer and closer until they do equal each other, and then we stop. And we kill this loop, this little coroutine, this little thread, we're done. But the problem with floats is that they don't act nice like integers. So we can say, while 1 equals 1 or 1 does not equal 2, we can do these determinant checks with integers, but floats, it's not as easy. There's a lot of rounding errors. These decimal parts run on for a long time. And so you can't say, while transform.position does not equal to end position. That doesn't really make sense in floats. But you can say a really, really small amount of difference. So vector 3.distance hides the math behind the scenes of checking a vector 3 against a vector 3. But since y and z are really don't change, they're zeros, we can just say, think about this in the x coordinate. So while the difference between our current x position and where we wish to end up is greater than a very small amount, we keep going. Eventually, where we currently are in our animation, our separate little loop, gets so close to where we want to go, it's less than this small amount. This evaluates to false, and we leave this separate loop. It terminates. Oops. So by default, we're starting at x is 0. We wish to get to x is negative 6, because this is the hide position we're passing in. While 0, the difference between 0 and negative 6 is greater than 0.01, which is true. We go in here and do this. So before I talk about what a lerp method is, let's just say that it moves the object just a little bit. We increment the amount of time that's passed, and then we yield. Yield, return, null. You've seen return statements before. Yield means pause. So while we're in this separate time loop, we're going to pause it and finish up our main game loop. Go into our next game loop, our next update loop, which means we'll return back to this statement, which means we'll evaluate this while loop again. It'll be true. We move the UI just a little bit, update our time, and then we yield, we hold again. So this little loop, each iteration of our co-routine is iterated as each time we move through the update loop, the main game loop. So here we are at transform. This should actually just be transform position. So we're going to update the position of our UI. What are we updating it to? Vector3.lerp feeds in 2 vectors and a time for float. So lerp means linear interpolation. It's actually very similar to when we were using the animation system. When we created one key and another key, and it did that like soft curves, it did that like soft transition between one point and another, give that like feel of momentum, of acceleration. I also was able to take the points and basically take their tangents and turn them to each other to make a linear interpolation. We start at one point, we end at another point, and we discretely move through each position change with the same amount of distance, meaning no change in acceleration. We go from point A to point B at a fixed speed, no change in velocity, most simplest animation, a linear interpolation. So if I quickly just drag in animated cube, open up the animation window, look at its curves, just press the F key. Here's crazy curved off interpolation, like a smooth curve interpolation. But if I take this point and angle it toward this one, we now have a linear interpolation from here to here. The same change across this time limit from, if I select 2, from this point in time to this point in time, the same distance change, the same change in values, same distance per time unit. Let me just undo it so my curves go back. Okay. So linear interpolation, the easiest, simplest math for dealing with the changing one value to another, and it's a function or a method that's already in the Vector3 class, so we're taking advantage of it. It works on vectors. So what is it saying? Where do you wish to start, or where are you starting from? Where do you wish to go over what amount of time? So it doesn't matter the distance you want to go through. It doesn't matter the amount of time you wish to go through it. This eventually evaluates from 0 to 1. How complete of a journey are you from 0% complete to 100% complete, i.e. 0 to 1? So start position, we record it up here. Before we even start to animate, where is this object currently sitting? Record that vector 3. In this case, we're starting from the show position to the hide position. We're going from 0, 0, 0 to negative 6, 0, 0. End position, we passed it in. We're going to our hide position, negative 6, 0, 0. At what part of the journey are we? Going from 0 to 1. going from a smooth change from 0, 0, 0 to negative 6, 0, 0. Well, elapsed time starts at 0. We just started the journey over a certain amount of time. So this is a public float so that we can change it later. And it's called anim time, which I think expresses the information about it. The amount of time it takes to complete the animation, 2 seconds, 5 seconds, 10 seconds, whatever you want. I have 2 seconds. So when we first start this, we have 0 divided by 2, or 0, meaning we've just started the journey, nothing has happened. We're still at the start position. Elapsed time then gets incremented by delta time. So I did the quick calculation in class. So the update loop is variable. It depends on how fast your computer is. It depends on how much code you have to run through each update loop. So if you have all these scripts in your application, all of them are doing something during the update loop, your app's going to run slower, and vice versa. So normally an update loop will run to 30 to 60 times a second. So let's just say, okay, it's running 30 times a second. 1 divided by 30. Let's say we moved one iteration into our update loop, and we ran this enumerator for the first time. Okay, it says 0.0333 of a second has just occurred to go through my update loop. So that's the little fraction of a second that gets added to our elapsed time. And then we yield. We put our little coroutine on hold. We finish up the major update loop of the game, the app. And then we come back in here on the next iteration of the update loop, and we check again. Did we finish our journey yet? No. All right, run the lerp routine. Now this number has grown just a little bit larger. It's moved off of 0. Now we have a small number divided by 2. And we moved a little bit in our journey from our starting vector location to our ending location. So eventually this number starts getting all these little fractions added to it as time passes. Eventually this number might get to 1. Right? 1 second has passed as we've been going through this coroutine. Our total trip time we wish to take is 2 seconds. 1 divided by 2, 0.5. We're halfway through our journey. So if we're moving from 0, 0, 0 to negative 6, 0, 0, halfway through that journey, we're at negative 3, 0, 0. And then this number keeps growing till eventually it's 2. It's been 2 seconds since this coroutine has been running. 2 divided by 2 is 1, or we're 100% complete with our journey, meaning where our transform position is, it's going to be very close to end position, close enough to be within 100th of a distance difference from where we currently are in our animation to where we wish to be, meaning this evaluates to false. We exit out and we're done. This little micro loop has terminated. This coroutine's ended. We finished our animation over 2 seconds. We moved from one vector to another. And we don't need to lerp anymore. And this coroutine closes and we're done. Then if the user clicks the hide button again, we're now in our hide position. You know, the little button sticking out a little bit. The user clicks it. All right, so here we are at is hidden is true. We wish to move to the show position. We're going to change is hidden to false because we're moving to a show position. We're going to start our coroutine, and over the length of this anim time, we're going to move to the show position. So I'm just going to talk about this part. Then I have to talk about this part. And we're done. So is there any questions between the button calling move UI? Move UI calls this enumerator, which spins off a little thread, and we're trying to get to this end position with all this. So time-based change of variables, so discrete that to the human eye it looks like animation, which is what the animation system is doing, but you see how complicated it gets. There's no way you can make creative decisions this way, or very good ones, which is why this animation system exists. Cool. So, as I showed you, the user can spam the button. So the amount of animation time, we could say, okay, take 4 seconds. Let's click play. Now let me show you how to disable this hide button so that the user can't just destroy your functionality, destroy your user interface. So I want to grab this button and mess with it. So I have public. First I had to say using uniengine.ui. Then I had to say, okay, it's a button I want to grab. Called it something, hide button. So now the script asks, what is this hide button? Then I can just drag it onto it. Now what do I want to do with this hide button? So at first I was trying to turn it on and off. So notice how the graphics of it don't go away, but the button isn't interactable. I wasn't able to find this like set active I'm used to calling by code, but I noticed here interactable. You can turn it on and off. So I was able to find that. So before we start animating it, but we're down in the coroutine, we're going to say hide button dot interactable, set it equal to false. Make the hide button not interactable so the user can't keep spamming on it while it's animating. And then when we're done moving, we make it true again. We make it interactable. Maybe another level, a better feature is that if the user does click on it while it's moving, it updates the animation. Oh, the user wants to go back. We were moving to hide, but now the user wants to move back into show. If maybe in a week or two I have extra time, I'll do that. But this is where I'm currently at. The only thing to talk about is this. So let me flip this. Let me say, if we're running in the editor, do this. So I'm going to click play. And notice when we first start the application, the UI comes out and greets us. I'm kind of discreetly trying to tell the user, hey, just so you know, there is this hide feature. So if you do want to start painting and it's in the way, you are able to hide the UI. So I kind of tell the user or try to indirectly infer that, hey, look, when we first start, this thing pops out. We're ready to go. Here's your UI. And just so you know, you can hide it back again. So since I'm working, we can do a check. The application, is it running in the Unity editor or is it out in the wild? Is the user using it on their computer? So if you're using it in the editor, this will evaluate to true. So since I'm the developer and I'm working in the editor, I'm trying to be very quickly with my changes and testing, I don't want this thing to keep coming out every time. I want it just sitting there for me. But for the user, I want them to have this nice graceful entrance. Right? So I check if we're not running in the editor, then put the transform at the hidden position, pop it immediately into hide, set hidden to true, is hidden true, run move UI. Move UI runs, is hidden is true, so we run this part. We're going to call the moving UI coroutine with the show position as our end goal. And then set is true into false because we're moving to that location. So that's the whole UI animation script. Is there any questions there? All right, I got 15 minutes. Oh, moving the paint strokes. So I covered UI updates. I covered animating the UI by code. Now I have to talk about how to move the paint strokes. And then we're done for the day. So over the next coming weeks, I'll talk about how to fix your prefabs if some of them are broken. Like my first prefab was basically broken with this system. I fixed it. I have to go heavy into my code, and then I got to show how to clean up modularizer code. So that's over the next 2 weeks. So all I'm going to do for the rest of this class is show you how to paint behind the UI. So originally it was doing this, painting on top of the UI. And originally, I got to go back into my code. This was active, and this was an X cutoff. This was originally at 200. All right, so what was happening was I was painting the objects halfway. Let me get out of maximize play. The camera is 10 units off in the Z. My UI is at 0. When I paint, I'm painting at 5 units off from the camera. So I'm painting objects in between the camera and the UI. And I hard-coded that. If you notice the mouse position down here, you have to be greater than 200 to actually paint the stroke. If you get less than 200 on the X, you don't paint. But it's kind of limiting. I have all this other screen real estate. Why not give that to the user? So first off, this is where I was checking where the mouse position is if I should actually paint the object. So if we're holding down the left mouse button and we're not currently interacting with something on the UI and our mouse is to the right 200 units from screen left, then I'm allowed to paint. So first off, I don't need that anymore. I can paint anywhere on the screen. And where am I painting to? So wherever I take the click position, wherever the mouse is, left, right, up and down, and then I add in this distance. How far should I be spawning these objects? Distance was initially set to just 5 units out from the camera, but I made that public. So I can change it to whatever I want. So I know the UI is at Z0, the camera's at negative 10 for Z. That's a 10 unit difference. So I need to be painting past 10 units. So I found something like 13 was good because the objects have some depth. They can cut into the UI. So now I'm painting behind the UI and across the whole screen. So those little 2 changes, now I'm painting behind the UI and all over the place. That UI is moving a little slow for me. Put it back to 2 seconds. Then somebody asked, can you check if the UI is showing or not? If the UI is showing, can you restrict how much you're painting? I said, sure. We can create a variable. I'm just going to call it X cutoff. It's a float. And then, before we check if we're about to paint, you got to check if the UI is shown or hidden. That's that bool that we can access. If the UI is showing, we set X cutoff to something like 200 units. And if the UI is hidden, we can set X cutoff to 0, meaning you have the full screen. Then you'd have to bring this back, and you'd put this check to X cutoff. And there you go. You can change how far the user can paint based on if the UI is open or not. I think I wrote the. No, that's pretty simple. So I can put that into my code. And I think I covered UI updates, UI animation, paint strokes. I disabled the hide button during animation. So I am good. So I'm going to cover that next week. I don't have enough time. But at the end of the day, you're going to get your app functioning like this. One stroke, two stroke. I'm using hotkeys. Let me turn off time destroy. One stroke, two stroke, three stroke. Seems like there's a big size difference between the right and the left side. I'll probably adjust that so that they're all relatively pretty similar. But everything works with size, everything works with glow, everything works with opacity, color. I can destroy everything. I can hotkey through the spawn types quickly. I can close out the UI, bring it back. I can hotkey through the animation types. I can randomize the speed. And then this is going to take some coding that everything remembers what its random speed is. And what this speed scale is really doing is relatively changing them all so that they all speed up a certain amount and all slow down, but they're all still random. And if I wish to randomize the type, my UI is keeping track of that. Watch how the numbers flipping around, what I'm ending up with. And that all these are still can be controlled by speed. Then if I cared to, I can randomize the type and the speed altogether. All right. Seems to be a little bug I still have to work out with. Looks like when I randomize everything all at once and I mess with the speed factor. I have to take a look at that. So this is where I want you to get your own project up to. And so I'm going to just continue. It looks like I have a few bugs to work out, but I'm not going to create any more features or functionality from that. And what that means is Sprint 4 deliverables, I listed all of them. You can read through them again. I want you to still do your own itch.io build. And this is new. I want you to think of two parts of your code when you're done. Take screenshots of them and talk like, what did you clean up or what you're most impressed by, interested by, that you fixed, cleaned up. Just talk about what you fixed in your own words. Yeah, in your posting you'll write, like, here's a screenshot of one part of the code. I did this, this, and this. Here's a screenshot of another part of the code. I did this, this, and this. And here's the link to my build. You know, something like this, but it'll be Sprint 4. And then that's it. Come in, drop that Sunday night, May 5th. Come in for a short, like 30-minute final. And we're done. And after the final, I'll be here for lab time. And for those who are still stuck in stuff, I can talk with you. All right. Any questions?